Good morning. Okay, it's time. Let's review. Let's do presentation. Okay, this presentation basically is a review last class. So right now we have covered polynomial functions, rational functions, and right now we are in two other kind of functions: exponential functions and logarithmic functions. So let's start. I'm going to make you presenters, so get yourself ready. All right, let's review for exponential functions and the logarithmic functions. Because we have many questions, so do A and B. Okay, if you choose a question, do both parts. Do both A and B.
From what I see on the chats, there's a lot of people that have not done the homework number 9.
Yeah, it's okay. Only for those people who have done it. Let's review it. So James 10. So I need to make you presenters. Your basically presentation, the big function of presentation is to help us to review, what we have talked about previously. Okay, so Ola, just get yourself ready. Yeah, if anybody has any questions, feel free to ask anytime.
I have not been assigned to be the presenter yet.
Oh, I see. Okay,
I'm
I'm
ready.
trying to do that.
No problem.
Wait, what?
Okay, I think I made you guys presenters. Let me see if I miss anyone. Okay, so Liz, I see your screen.
Yeah.
Go ahead.
So I'm going to be presenting from homework 7, question number 53. So we are supposed to basically find the intercepts and asymptotes, and then sketch a graph of the rational function and state the domain and range. And then I basically crafted two. So for this functions, we have the the x and y intercept. The x-intercept is 1, 0, and then the and negative 2, 0, and the y-intercept is 0, 2 or 3. The vertical isotopes is x equals negative 1, 3, and horizontal isotopes is y equals 1. The reason why this is not I am not showing my work is because I just usually follow like the steps and I do it in the calculator altogether. So sorry about that. But I basically put it here too. Like for example, find the y-intercept, substitute in 0 for 1 and then so for x. So if you don't have like an idea of how I did this, I wrote it here. And then at the end, the domain is negative infinity, negative 1, negative 1, 3, and 3, infinity. And for the range, there is negative infinity, infinity, positive infinity. And here is like the representation. So these lines basically represents like for us to find the asymptotes. So for instance, so for the vertical asymptote, we have x equals negative 1, 3. This is because, for instance, this line almost but never touches or is never equal to negative 1. So this graph is just like showing it everything in case you don't get this here. So yeah, thank you.
No, Liz. Okay, let me ask you a couple of questions.
Okay.
First is the work. Looks great.
Mhm.
I just need you to fill out some details. Helps all of us to review.
Okay.
because
Okay.
graphing rational functions is very difficult. It's very difficult. So let's review some of these concepts. But I like you writing here x-intercept, y-intercepts in the point form. So x-intercept, we have 2 points. Y-intercept, we have 1 point. Great. I just need you to give me a little detail about how you get to x-intercept. What did you do?
Wait. I'm sorry.
So,
My screen went off for a second. Can you repeat that?
oh, I still see your screen.
Okay.
You see you have x-intercepts, right? You have 2 x-intercepts. So I
Yes.
just need you to tell me, right, because I don't see any steps here. Just give me a little detail.
Okay.
Help to review. How do we get, we have this function, rational function. The numerator is in a factor form. The denominator is in a factor form. It's kind of easy for us to get x-intercepts and y-intercepts. I just want to know, how do you get your x-intercepts and the y-intercepts from the definition?
Right. So I would do it next time because I'm personally like very rushed. For the next time, for the next homework, I will detailedly basically answer the question. Then for this one, I'm sorry.
Okay, let's see. Let's do this together, Liz. You
Okay.
see x-intercepts. You see the 2 points. What's in common of those 2 points? What do they have in common? Do you see y value equals to 0?
Mm-hmm.
So that's
Yeah,
the definition.
the y's values are all zeros.
Yeah, that's the definition of x-intercepts, right?
Mm-hmm.
So from the definition, so that means the y value is 0. So we set this function r of x to be 0. Make sense?
Correct. Yeah.
Right, because the y value, the function value is 0. Okay, now for a fraction to be 0, only the numerator can be 0, right?
Yes.
So when we set this function to be 0, that is the same to say the numerator is 0. The numerator is already in a factor form. For a factor, if something multiply something to be 0, we can use something called a 0 property, right?
Mm-hmm.
What does the 0 property say? So we have 2 factors. We have x minus 1 as a factor. We have x minus 2 as a factor. If one expression times another expression to be 0, that means that either expression can be 0, right?
Yes.
Okay, so how can you make any conclusion from there?
Okay. Wait.
I'm helping you to type in the chat, help you to think. You can see in the chat, right?
Mm-hmm.
The function to be 0, that means because we have rational function, that means the numerator is 0. And we have 2 factors. So x minus 1 is a factor, x
Mm-hmm.
plus 2 is a factor. When we multiply those 2 to be 0, that means either one of them can be 0, isn't it?
Yes,
This
but
is
then
how
they become like the opposite signs, which is
okay, so can you solve these 2 equations? So x minus 1 is equals 0, x plus 2 equals 0. That gives us 2 solutions.
yes, they will become x equals +1 and then x equals -2, which is what I have here.
Perfect. Right. See, that's how you solve, that's how you find your x-intercepts.
Mm-hmm.
Okay, so is it possible you can you try to fill in the detail now?
Yes,
Okay.
but you want me to do it like now? That's what you're saying? Because
Yeah, so but if you know how to do it now, you know how to do it next time, right?
yeah, correct.
Okay,
But
so let's
as I mentioned, like that's why I put myself first to present today because I'm actually in a rush. So I'm here presenting, but I have to go. Like I'm not gonna be.
no, you have your answers right?
Yeah,
Just
yeah.
to fill in details. So now you have the details, right?
Correct.
So let me ask you again, how did you find your x-intercepts?
Well, so we just talked about here in the chat. So I put basically the y-intercept. For the y-intercept, I substitute in 0, and then for me, so for x, when I have x, once I have x, I substitute the x into the y basically, and then I solve for y.
Oh, are you talking about y-intercept?
Yes, I'm talking about both. Like I just gave an explanation about both.
No, the definition of both is different, right? Let's try x-intercept first, then we deal with y-intercept.
Okay, go ahead.
Okay, so how did you find your x-intercept again?
I substitute in 0 for y, and then I solve for x. So for instance, here is my y. So here is my y. I substitute in 0 for each of the x values, and then I proceed to basically do the calculations for me in order to get this. This is how I did it. But you have like a different way to do it. I did it differently. What I did was I substitute in 0 for the value here, the variable here x, this is our y, and then I substitute in 0 for each of them, and then I proceed to do the subtractions and additions and all that.
Okay, let's try one more time.
Okay.
Okay, finding x-intercepts. So the function value is 0. So just like you said, you substitute r of x into 0.
Yeah.
Right? So you have this, the x minus 1 times x plus 2 divided by x plus 1 times x minus 3 equals to 0. Right? So this expression equals 0. That means the numerator equals to 0. Does that make sense?
Like all the numbers on the numerator, you mean here?
Right. X minus 1, x plus 2 equals 0. For the whole thing to be 0, if and only if the numerator equals to 0. That's the key. That's the key part to solve this, to find this x-intercept. Does it make sense to you?
Yeah, makes sense.
Okay. So now you have x minus 1 times x plus 2 equals 0, right? Then I type in the chat. We're applying the property called the zero property. If something multiplied by another thing equals 0, one of them or both of them to be 0. That means you can split them. So that's what you can write as x minus 1 equals 0, x plus 2 equals to 0. Does that make sense?
Yeah, kind of. I will have to review more about it because, as I said, I kind of do it differently. I kind of do it in my way once I don't understand something. But yeah, I'm kind of comprehending what you're saying now.
Okay.
Hopefully this is good. But I have
this is this is not like a complete, all right? Because you're not able to tell me how did you get x-intercepts. Your answers are right. Okay, so now I hope you get right. I hope you practice on this finding x-intercepts. All right, now let's try find the y-intercept. Can you tell me how do you find a y-intercept?
For the y-intercept, I substituted in 0 for x, and then I solve for y.
Great. So for x-intercept, you substitute y or r of x equals 0. You're trying to solve for x. Okay, all right. Now let's go to the vertical asymptotes and the horizontal asymptotes. All right, so can you tell me how do you get a vertical asymptotes?
Yes, so for instance, using this, because this is the main graph. So for the vertical asymptotes, we can see here that this line, for instance, is almost touching, but it's not touching this line here, which I drew to basically demonstrate it. And this is -1. So we have the first the vertical asymptote, which is -1.
Yeah, because it's -1. You're right.
Yeah. And then for the 3 here, this is the demonstration of it. It's like a line that almost but never touches this line or the number here. So this is the asymptote for that I have here.
Right, vertical asymptotes.
Yeah. And then for the horizontal, this is basically it. Like this graph here or this graph here is just basically showing that it almost but never touches the one value here on the vertical axis or the y-axis.
Okay, great. So my question is, right, how did you find vertical asymptotes? And how did you find horizontal asymptotes? Let's do the first one first.
Okay.
Can you fill in the detail? How do you find vertical asymptotes for x equals -1 and x equals 3?
Well, at first I tried doing it like the book says, like, by comparing the degrees of the numerator and the denominator. Then to make it easier for me, I just basically put this into a calculator and it gave me the graph, and I just basically try to look at the lines and how they almost touches like the
I
values,
see.
yes, on the x and y intercept.
Okay, I see. That's one way to get it, but sometimes we, for this purpose question, the purpose of this question, we need to find vertical asymptotes without the graph yet, because our purpose is to be able to graph it. Let's
Makes
go
sense.
back to the function. What's in the denominator of the function? X plus 1 times x minus 3, right?
Yes,
Right. So how do we find the vertical asymptotes? We set the denominator to be 0.
makes sense.
Because if the denominator to be 0 is not allowed in mathematics, that creates these vertical asymptotes. These vertical asymptotes is saying -1, x equals to -1, and 3 is not in the domain. Just like you wrote on the right-hand side. You said the domain of this function, you see, not including -1, and also avoid 3.
Got it.
But how do we get it? We set the denominator to be 0. We check to see when, what kind of x value will cause the denominator to be 0. You see, if x is -1, -1 plus 1, that will cause 0 in the denominator, right?
Mm-hmm.
Same thing if x equals 3, 3 minus 3 will be 0, also will cause 0 in the denominator. So that's how we get vertical asymptotes. Does that make sense?
Yeah, makes sense.
Okay. Now, horizontal asymptotes, remember we said we take the leading term of the numerator. We take the leading term of the denominator. Something is like ignoring the lower terms. We only compare the leading terms. Can you tell me what's the leading term in the numerator?
I got 1.
Leading term. Leading term means the variable has the highest exponent.
Oh, well, -2.
So if x minus 1 times x plus 2, if we expand x minus 1 times x plus 2, what do we get?
What was that? Sorry.
So we need to find the leading term, right?
Yes.
So how do we find the leading term? We
Give me a
need to multiply. We need to multiply those two factors. How do we multiply those two factors? Some people call FOIL, some people call double distribution.
Got it.
So do you know how to FOIL or how to do double distribution?
I'm not 100% sure, but
Do you like to try it?
not now, because as I mentioned, I'm basically presenting, but I have to leave the class.
Okay, right. That's it. The purpose of presenting is to show you understand the material, right?
Yeah, but
Yeah.
I also, most of it, the thing is that I don't show my work. So that's why next
Let's
time,
try
as I mentioned, I will
Yeah,
do work very detailed and I will present it for people, students, in order to understand.
okay, so do you like to retry next time?
Yeah, I would like to try next time since, as I
Okay,
mentioned,
thank you very
I did
much.
it very rushy and stuff. So that's why I don't have like the very detailed. But like the
Okay.
past presentations, I don't know if you remember, I am very detailed. So I hope
Okay.
this is not bad at all.
The answers are right. I just
Okay,
need the details. All right. I just
definitely.
need the details. So just try next time. All right. Thank you very much, Liz.
Okay, same.
All right. Next one.
Hello, Professor.
Yes. Hey, Ola.
Hello. I'm trying to present number 59.
Number 59.
The one,
Okay.
yeah, I don't know how to expand it. I told you about that earlier, so I'm just going to show both of them, but starting with number 59.
So let's try it because this chapter is very difficult. This section is very difficult. Graph rational functions probably is among the most difficult tasks.
Question
Okay.
59, right? So go ahead.
Yeah, I see your work here. You can go ahead
Okay.
and explain what you did.
So basically, r of x equals x squared minus x minus 6 divided by x squared plus 3x, right? So the first thing I did was to find like the factor form just to make it a little bit easier. And then the next step, the first thing we're supposed to find is the x-intercept. So to find the x-intercept, just set r of x equals 0. So that r, like we said, set r of x equals 0. So 0 is equal x minus 3, x plus 2 divided by x and x plus 3. So you, wait, did I say cross multiply? Yeah, you cross multiply. So when you cross multiply, you have 0 times x, 0 multiplied by the denominator, and the numerator multiplied by 1, which is basically stays the same. So the next step is to anything multiplied by 0 is basically 0. So the left side becomes 0, and then the right side we have x minus 3 and x plus 2 equals 0. So we say each factor equals 0, and then x minus 3 equals 0. The final answer equals x equals 3, or x plus 2 equals 0, and the final answer is x equals negative 2. And for the y-intercept, substitute x equals 0 into r of x. So basically, wherever you have x, you put 0. So if we do that, what we get on the numerator is negative 6, and on the denominator, we have 0. So since we can't divide by 0, basically the answer is undefined. Therefore, there is no y-intercept. Good?
Ola, we lost you.
Really?
Oh yeah, you come back.
So did you wait? Where did you get me?
Yeah, just a little bit. Keep going. It's great. I love it. Keep
Okay.
going.
So for the vertical asymptote, whatever it is called, yeah, that. So set the denominator equals 0. So basically, we're gonna set x bracket x plus 3 equals 0. So we're gonna split it apart. I don't know if it's called split apart, but yeah. So we have x equals 0, or x plus 3 equals 0. So x equals 0 is basically just x equals 0. X plus 3 equals 0. If we solve that, we get x equals negative 3 plus 0. And the final answer is going to be x equals negative 3. And then for the horizontal asymptotes, since the degree of the numerator and denominator are the same, we're going to have y equal, the horizontal asymptote is going to be equal to y equals 1 divided by 1, which is basically 1. So that's that. And then next, for the graph. So for the domain, since this is the domain right here, x is not equal negative 3 or 0 and 0. So since the vertical asymptote is at x equals 0 and x equals negative 3, we definitely know that like x cannot be equal to those two numbers. So that's why the domain is at. It's not, that's why the domain is x is not equal to negative 3 or 0. And then for range, it could be negative x to infinity. something like that. Yeah, negative to infinity. Which is so the explanation for the range is piece of the graph between x equals -3 right here and x equals 0 as points for every real value of y. And this is the table of values. Basically, we try to get as much points as possible just to, help us with the graph. So you just basically what I did was substitute x value into r of x, like find the r of, for example, r of -15, and like that. And yeah.
Okay, looks great. And just one question.
Oh my God.
Here we have horizontal asymptotes, right?
Mm-hmm.
And horizontal asymptotes is y equals to 1.
Mm-hmm.
What does it mean? That means 1 is not in the range of this function. So then, how do we write our range? Our range should be go from -infinity up to 1, then parentheses, then union 1 up to positive infinity, because 1 is not in the range. That's horizontal asymptotes.
Oh, okay.
So that's the only thing, okay? But
Yeah.
great work. Beautiful work. Thank you very much. Anybody has any question?
Oh, please don't. Thank you.
Okay, thank you, Lo. Okay, next one.
Okay, so I'm presenting 57, which is r of x equals 2x squared plus 10x minus 12, and the denominator is x squared plus x minus 6. So to find my y-intercepts, I just plug in 0 for x, and for the numerator, I got x equals -12, and the denominator x is -6, and then I divide the two, I got 0, 2, which is my y-intercept. Now to find the x-intercept, I use the quadratic formula and I plug in the value for the a, b, and c, and I ended up x is equal to -6, 0, and the other solution is 1, 0. And for my vertical asymptotes as well, I used quadratic function and I got my two solutions over here, -3 and +2. And for the horizontal asymptote, I just divide the leading terms for the numerator, which is 2x squared, and for the denominator is x squared. So I divide those two, x squared just is gone, so I got left with 2. And to find the domain, I take the numerator and I set it not equal to 0. And then I use factoring and set it also not equal to 0. And then I'll solve for x. For the first solution, x is not can't be 2 and x cannot be -3, and the range is from -infinity to +infinity. And for the graph over here, I know you're not seeing the sketch of the asymptotes, but I can explain that. I forgot to include it. So for the y-intercept is 0, 2, you can see over here. The first solution for the x-intercept is 0, -6, which is over here. The last one is 1, 0, which I pointed over here. So for the vertical asymptote, since it's -3, that will be down here. The line will start from here and cross the y-axis all the way to the side. And x is 2, that will be over here going down for the like vertically. And I'm sorry, that's for the horizontal asymptote. X is 2, so that will be going down from this side. And
That's
yeah, that's it.
Together, there's a vertical asymptote. Okay, it's
Yeah.
the graph looks good. Let's wait. You did most of the things right. Let's just go check some points. All right.
Okay.
First, you're trying to find x-intercepts. Is that what you did? You use
Which
quadratic.
part you talking about?
I'm
Yes,
talking about
to
you have
find my two values.
Hold on a second. I'm seeing you have x equals to -3, x equals to 2. So you're trying to find the vertical asymptotes. Are you?
I already have the vertical asymptotes over here.
So that's okay. So x equals to -3, x equals to
And
2.
x equals
That's your
2.
two vertical asymptotes, right?
Yes.
All right. So remember,
And my horizontal asymptotes is 2.
it's a 2. It's a y equals to 2. You mean, right?
Yeah, y equals 2. Yeah.
Y equals to 2. All right.
Yes.
So what's the relationship between vertical asymptotes and domain? Vertical asymptotes is saying
It have like the same value as the domain because I'm using the same function to find both of them, so I'm getting the same answer.
that's right. So the vertical asymptotes tells us the value is not in the domain, and that which you perfectly indicated. X is not 2. X cannot be 3.
Yes.
Okay.
Right here.
So you did it twice. You see, you did one in factor form. You solve the quadratic equation in two different ways.
Yes.
Then you did
Just
one.
want to show my work.
Right, the first one you did it with quadratic formula. The second one you use a factoring strategy.
Form.
You
Yeah.
only have to do once, but it's okay. All right, so you
Okay.
miss right. You're missing. Let's now talk about our range or the horizontal asymptotes. So
Okay.
horizontal asymptotes is y equals to 2.
Yes.
That is to say, 2 is not in the range, right? Because when y equals to 2, that creates horizontal asymptote. So
Yes.
how do you think, what should we, so your range right now is from -infinity up to +infinity.
Yeah.
But 2 is not in the range. So how would we rewrite this?
But I didn't include 2 in the range, so I'm not understanding what you mean.
Okay, so horizontal asymptotes, right? What does horizontal asymptotes indicate? Indicates the value is not in the range. So here we have y equals to 2, right? Just like a domain.
Which
Just like a vertical asymptotes are saying the x values are not in the domain of the function.
Okay.
The horizontal asymptotes is saying the value y equals to 2 is not in the range of this function.
Okay.
So we would write from -infinity up to 2. I don't know why. Sometimes I can write, sometimes I cannot. I'm gonna write in the
Yeah,
chat.
because I'm not seeing it.
Right, I'm gonna write in the chat. Okay, -infinity up to 2, then unit -2 up to +infinity. In this case, we just avoid, right, the value of 2. We're not including 2 in this set of values. So basically we're saying the range means the y value can be any real number but 2.
Okay.
Okay. All right. Thank you very much. Anybody has
You're
any
welcome.
questions? All right. Who's next?
Hello. Are the presenter?
Oh, have I? Yeah, you are presenter. Jeremy, right?
Yes.
Yeah.
You see it?
Not yet.
Oh no.
Yes.
Okay. So basically, this is homework 9, question 8. And basically, all I had to do was I didn't have to plot any points. I just had to like create the graph from figure 1, which is y equals e to the x power. And the dashed line is the original, and the solid line is y equals 1 minus e to the x power. And I got the horizontal asymptote because the solid line and the dashed line seem to have a connection with y equals 1.
Jeremy?
Yes.
Oh. Are you still talking?
Yeah. Can you hear me?
Yeah, we can hear you now.
Okay. So basically, what was this is y equals e to the x power, which is like in figure 1. This is the original, and the solid line is y equals 1 minus e to the x power. And I got horizontal asymptote y equals because this is where the connection between the two lines. It seems to have a connection with y.
Okay, let me ask you some questions, right? So, but let's review a little bit. What do we have, right? What have we done in class? We said, okay, we're treating y equals e to the x as a reference graph, right? As our reference graph. So now we have this y equals 1 minus e to the x. We said this is a
flipped over.
transformation, right? So this function is a transformation of the e to the x function. So what is the transformation? First, we see that's negative e to the x.
Yes.
So we negate the y value. That creates reflection over x-axis. Right, that's what we talked about last class. It's still new. So we started from e to the x. Now we're seeing negative e to the x. So the y values being flipped over. So before we have this graph on top of x-axis. So the negative of it flips over down on x-axis. Then we have this plus 1. So 1 minus e to the x, we can see as negative e to the x plus 1. Plus 1, remember, is what kind of transformation?
Is
It's a
that vertical?
Right. Because translation, we have two kinds of translation, right? We have vertical translation, we have
Horizontal.
horizontal translation. So here, adding 1, we have a vertical translation. So basically, all the y values being pushed up 1 unit. Does that make sense?
Yeah.
Okay. So now, so we can graph that, right?
Yes.
So that's why you are seeing, we don't call it horizontal asymptotes or anything. We call line of symmetry, if you want to talk about that. So y equals to 1. No, I don't know why you read horizontal. I don't think this helps us, y equals 1. How does y equals 1 help us here? Oh, okay. You were saying, okay, the function y equals 1 minus e to the x has a horizontal asymptotes. Okay.
Yeah.
Horizontal asymptote. Now I understand you. Okay, great, great. You were saying, okay, the graph is under the line y equals to 1. Yes.
Yes.
Right. Y equals to 1 is the horizontal asymptotes. Okay, looks great, but it's just, sometimes we need a little bit of detail. All right, so to say, okay, negative e to the x is a reflection of e to the x over x-axis. That sounds like a mouthful. Let me just try again. So first we see this function as two parts, negative e to the x plus 1.
Okay.
So negative e to the x is a reflection of e to the x over x-axis. Does that make sense?
Yes.
Okay, now adding 1 to it, that's a vertical lift, 1 unit.
Right.
Do you see you flip over this dotted line, then you add 1 to it, you lift it up 1 unit. Because if you flip this dotted line, that would be under x-axis.
Right.
Then you pushed up 1 unit. That's how you have this solid graph.
Yeah.
Okay, Great, Jeremy.
Thank you.
All right, you're welcome. Just make sure next time I have a little more detail. Anybody else?
Yeah, Professor, I'll go next.
Okay, have I made you a presenter yet?
Yep.
Okay.
So, can you see my screen now, Professor?
Yeah.
Okay. So I'll be doing homework 9, number 10A. It's basically transforming the logarithmic expression to this one. So for number 10A, it's going to be log base 3 81 equals to 4. And its expression form, it will be 3 raised to 4 equals to 81. So yeah, that's about it.
Okay, can you explain B too?
Oh, sure. For B, log base 8 4 equals negative 2 over 3 will become 8 raised to negative 2 over 3 equals 4. So yeah, that's about it.
Hold on a second. Are you sure A raised by negative 2 over 3 equals to 4?
Yeah.
Because A, can you explain why?
Because if we were following the instructions on how to transform this into expression form,
Oh, okay. You just rewrite it. Okay, you just rewrite it. I see.
oh
Okay. Is this negative? Oh,
yeah,
negative, right. It's negative. Let's see. 2 to the 3. 3 times, you get a negative 2. That would be negative quarter. You sure this is a negative 2 over 3 or positive 2 over 3?
can I show you the assignment in the textbook, Professor?
Right, let me see. This is question 10, right?
Yeah.
Question 10
Did I
is
miss
positive 2 over 3. It's James.
Hmm?
This should be positive 2 over 3 because it
Oh,
wouldn't
really?
make sense, right? Because if it's negative, you should get a 1 quarter.
Oh, so it's
You miss,
no.
right?
I
This is
just
a typo.
typo. Okay.
Do you see that? Do you see why? Why this
Yes.
has to be positive? All
Mm-hmm.
right, but basically, you know, if we change this negative to be positive, you are totally right. So you mean in log base A 4 equals 2 over 3 can be written as base A raised by 2 over 3 equals to 4.
So it's positive.
Right.
Okay.
Okay, let's go back to the first one, 10A, right? I just
Mm-hmm.
don't like this equal sign. This equal sign doesn't make sense.
Oh yeah, about that. Sorry about that. I just made it even more confusing. Sorry about that.
Right, don't write the equal sign in between. They do not equal to each other. So
Okay.
can you explain to this, the first one, A?
Mm-hmm. So why it became this one, Professor?
Right. Just tell us the process, right? How you
Oh,
rewrite log form into exponential form.
okay. So for my understanding, seeing this base, we'll just move it up, and seeing this one, we'll make it big. We'll make the 4 into an exponential, into a, what do you call it? A degree, and 81 will just move over to the other side. That's how I do it mostly.
Okay. Or maybe we can think this way. Let's try. So
Okay.
log base 3, 81 equals to 4. So we can write as base in log is a base in the exponential form. So
Mm-hmm.
here log base 3, we still write base 3. Now, just like you said, log
Mm-hmm.
indicates exponent. So that becomes 3 raised by 4. So 4 become exponent equal
Mm-hmm.
to the value inside 81.
Mm-hmm.
All right. Okay. Good job, James. Anybody has any question? This is very new material. We just need to get used to it.
Section.
Anybody else? Oh, Andy. Oh, no. That's Andy, right? No, that's James. Okay, Andy. Yeah, I have made you a presenter. Okay, Andy is going to try 11. Before. Okay, yeah, I see your screen, Andy. Go ahead.
Can you hear me?
Yes.
So my question is 11. We're asked to sketch the graph of the function by making a table of the values. 11 is f of x equals 1 over 3 to the x power. So it's pretty easy. You just have to substitute with x values on the x power and plot the points. For -4, you substitute the x with that and gives you 81 and 83, 27, and so on. That's basically it.
I see. Okay.
You want me to explain 15?
Oh, that's okay.
Or
Maybe
just one question?
just explain to us when x equals to -4, how did you get f of -4 equals to 81?
So since it's gonna be a negative exponent, and you could just do 3 to the 4th power, and it gives you 81.
Right, so you will see 1 over 3, we can write it as a 3 raised by -1, right? And then when x is -4, -1 times -4 gives you +4. So that becomes 3 raised by 4, 81.
Yeah, 3 times 3, 4 times is 81. Positive
Okay,
81.
all right,
And you plot the points.
right. And so this kind of graph, right, is decreasing, right? The function decrease.
Yes.
And then we call this exponential. Because remember, exponential functions, we have two kinds, right? So one kind is the base is bigger than 1. If base is bigger than 1, we have upward graph. We have increasing function. And we call exponential growth. And this one decreases because 1 over 3 is less than 1. We call this graph exponential decay.
Okay, yeah.
Okay, for exponential functions, we only have these two kinds of graphs. Either when the base is bigger than 1, we have increasing function. We call exponential growth. The other one we call exponential decay. All right, thank you, Andy.
You're welcome.
Let's see, anybody else? Anyone has any questions or anybody else like to present any other homework? All right, if not, let's go back to our textbook. I know you haven't finished because we just covered this on Wednesday, so it's very new to us. Let's just review a little bit. Maybe we use this, right? So log, let's start from here. Let's start from exponential equation. So e to the y, so e, right, again, if we remember, we call Euler number, right? You know, we can remember as a 2.172a, just like a pi. It's a constant. It's an irrational number, which means this number cannot be written as a fraction. So we write as e, Euler number. So e raised by y equals to x. We can write in a logarithmic form. We can write as log base e x equals to y. Okay, that's why whenever we see log, it's kind of confusing. you think that's the exponent of the base. All right. So ln is a short writing for log base e. All right. So ln we call natural log. So in calculus, basically we only use ln, and we will see later on why. So e to the y equals x, we can write as ln x equals to y. And we don't see base for ln, the base is e, all right, natural log. And then we have some properties. Okay, let's go through these properties. So log 1, doesn't matter what kind of base. In this case, it's base e. Log 10 raised by 1, log base 10, 1 equals 0. So log of any base, if the value is 1, that gives us 0. In this case, the base is e to the 0 is 1. Because anything raised by 0 is 1. Again, always remember, when you see logs, when you see log with a base or ln, you know, register in your head, that's the exponent of the base. So 0 is the exponent of the base. The base is e, so I have e to the 0 equals 1. The second one, 1 is exponent of the base. Base is e, so e to the 1 equals to the e. Same thing for 3, right? Base is e. X is exponent. Whenever you see log, that's the exponent of the base. So e to the x equals to e to the x. Number 4, so here we have exponential form, but the exponent is in log form. So e to the exponent equals to x. We can write it in log form, right? We would write a log base e, which is ln of x, well, of course, equals to ln x. Right? So if this is confusing, log in the beginning can be very confusing, right? Because we don't use log in life. But just remember, register in your head, whenever you see log of an expression, that whole thing is an exponent of the base. Okay, let's cover examples. So ln e to the a equals to the a. Ln 1 over e to the 2, we can write as ln e to the negative 2, that equals to negative 2 by using those properties. Ln 5, what do? We have to consult with our calculator. Our calculator will give us approximation. All right. So left you some homework. So homework 9. So keep doing homework 9. All right. So hopefully next class, we'll have someone keep presenting. So today we're going to talk about all right, so today let's talk about the domain of logarithm functions. And I'm going to assign you some homework. Hold on a second, let me see. Right, we covered this yesterday a little bit, but did I leave you homework for finding domain? No, not really. So let's try this. You know, talking about functions, right? We always care about what kind of value of in the domain the function can work with. So let's see this example. Find the domain of the function. The function is ln of 4 minus x squared. All right. If we remember, right, so this graph is log x, ln x. So y equals to ln x, or f of x equals to ln x. We could see that's an inverse. We talked about this last class. It's an inverse function of the exponential function of y equals to e to the x. And the e is bigger than 1, right? So in exponential function e to the x, we know it's exponential growth. So have this kind of graph. And the passes the common point. 0, 1. Right? And it's in between of e to the 2x, f of x is equal to 2 to the 2 raised by x and 3 raised by x, because e is in between of 3 and 2 and is closer to 3. But let's review the graph. So have a little bit of idea in your head, what does it look like? Okay, so base 3 bigger than 1, base 2 is bigger than 1, e is bigger than 1. So 3 graphs will be exponential growth. And because e is in between of 3 and 2, we see the blue color is the graph of 3 raised by x. The green color is the graph of 2 raised by x. E is closer to 3, so you see E is a red color. It's a red color. All right, so with this in mind, we think about lnx. lnx is log base e to the x, and it's an inverse function of e to the x. So we have e to the x, its inverse is lnx, and remember inverse functions. The line of symmetry for inverse functions is y equals to x. Okay, the line cuts first quadrant and third quadrant into half. So every point on this line, x value and y value are the same. So inverse functions are symmetric with this line of symmetry, y equals to x. So try to put this graph into our head, all right? So this helps us to think, okay, exponential growth, we get this kind of graph. And the logarithm functions, we get this kind of graph. You know, it's always to have kind of picture in our head as a reference graph to help us to think, to understand the function. So for logarithm functions, we have this common point, 1, 0, right? For exponential, 2 to the x, 3 to the x, e to the x, we have this 0, 1 as a common point. For log function, log base 3x, log base 2x, log base 10x, log base ex, we have this common point, 1, 0. Right? Because ln 1 equals to 0, right? When the value equals 1, the exponent is always 0. Okay, so with this graph in mind, let's think about the domain of this function. And we can see from the graph, okay? We can see from the graph, the red line, you know, getting closer, when the x value getting closer and closer to 0 from 1, the red color of the graph getting closer and closer to negative infinity, right? It goes down. It goes down. So what's the domain? The domain is x has to be greater than 0. X is greater than 0. Right? So that's the domain of logarithm function. So inside the log has to be greater than 0. Right? Remember, this x is just a variable. This x can be very complicated expression. Now let's go to our example. So you see what's x here in ln? That's 4 minus x squared. So inside the log, ln is 4 minus x squared. And we require this greater than 0. So we're writing as this. We're writing as 4 minus x squared greater than 0. So this is the inequality. So now let's try to solve this inequality. So we move negative x squared to the other side of the inequality sign. So we get x squared less than 4, right? The sharp point is pointing to x squared. So we can write as 4 greater than x squared. Right? If we move negative x squared to the other side, that's x greater than x squared. And this inequality is exactly as x squared less than 4. Right? 4 greater than x squared is the same as x squared less than 4. And when will x squared less than 4? That means absolute value of x less than 2. Right? So when will be negative? When will, let's see, this blue color is 0. Let's see this. So let's see this is 0, right? Absolute value is saying the value, the distance. Ignore the sign. Ignore the sign, right? The distance from a point to 0 is less than 2. So that means x is from negative 2 up to 2, right? Negative 2 up to 2. So that's why the domain for this function is x has to be in between negative 2 and 2 without the negative 2 and 2. So that means x has to be bigger than negative 2 but smaller than 2. Or we can use interval notation. The interval notation with open parenthesis, close parenthesis means negative 2 and 2 not included. If we want to include those two values, we use bracket. We use a bracket. So with open parenthesis, close parenthesis means negative 2 and 2 not in this set, not in this interval. All right, let's try a couple more examples. Let's see 50, right? 50 inside ln is x minus 2. So what do we do? To find the domain of this, we write x minus 2 greater than 0. We solve this. How do we solve this? X is positive, right? Negative 2, we just add negative 2 on both sides. Or we move negative 2 to the other side of the inequality sign. So we get x greater than 2. And that's it. So if we want to find the domain of this function 50, the domain is x has to be bigger than 2. Okay, that's how we find the domain. Well, let's try more. Let's try this one, right? All we care about is the inside the log has to be greater than 0 or positive. So we take 1 plus x greater than 0. When we try to solve this with minus 1 on both sides, we get x has to be greater than negative 1. If we talk about domain of this function, well, 1 is just constant. It's independent of the variable x. So we don't have to consider it. So we have to consider this part. Inside the log has to be positive. So we write 1 plus x. Positive means greater than 0. We solve this inequality with minus 1 on both sides. We get x greater than negative 1. And that's it. That's the domain of this function. Well, let's try more. Let's choose a couple from here. Let's see this one, 70. All right. Again, we do the same process. We take the expression inside the log, which is x squared minus x, and we see this has to be positive. Has to be positive means it has to be greater than 0. Then we need to solve this. How do we solve this? As if we solve for equality. All right, so we would do x, we would put in a factor form. We factor out x. So factor out x, the first term left with x. We factor out x for negative x. We have negative 1 left. We put in a factor form. So x squared minus x, we put in a factor form as x times x minus 1. Right? Because x times x still have x squared. X times negative 1 will have negative x. So we can write this expression into a factor form. Now we have to consider those two, when those two will give us positive value, right? That means when the two agree with the signs. So this is the solving inequality. I'm going to move here. I hope you still remember how to solve inequality. So I have two factors here to consider. Right? I have x times x minus 1 being positive. And then I have two situations. One is x being positive and x minus 1 being positive. Right? That means x is positive and x minus 1 being positive. The first situation. Another situation is both being negative, because negative times negative is also positive. I have two situations to consider, right? If both factors are positive, that's the first one, x positive, x minus 1 positive. And the second one is both negative. Negative times negative, also positive. So x be negative, x minus 1 be negative. Now let's solve this. Let's solve these two inequalities. So this one gives x greater than 0 and x greater than 1. Right? What's the intersection of those two? If x is greater than 1, x must greater than 0. But if x greater than 0, maybe half is not greater than 1. So the intersection is x greater than 1. If you're confused with this, you can draw a number line, right? Think about number line. So here maybe 0, here maybe 1, oops, right? If x is greater than 1, that's from up to here. Greater than 0 is here. What's the intersection? Intersection is all those. So that's why the first solution is x greater than 1. Let's see the second one. The second one is x less than 0 and x less than 1. If x less than 1, so we put arrows here, less than 1. Then less than 0. What's the intersection? The intersection is x less than 0. Because if x is less than 0, must be less than 1. But if x is less than 1, let's say half. Half is not less than 0. So the intersection of those two is x less than 0. So we have two solutions in the end. X less than 0. So then what's our domain? Our domain is either x less than, well, let's do the first one first. X greater than 1 or x less than 0. Let me see, maybe I put it on top. Okay, let's see if this makes sense. So we want to find the domain of this function. right? The domain is saying inside the log has to be positive. So what's inside the log? It's x squared minus x. So take x squared minus x. We said it has to be positive. That means it has to be greater than 0. How do we solve this inequality? We try to factor this expression. So we factor it, factor as x times x minus 1 greater than 0. So we have two factors, one times another, to be positive. That means both can be positive or both can be negative. If both positive, I have this first situation, right? That means the factor x is positive, factor x minus 1 is positive. I try to solve this. So then the second one gives me x greater than 1, right? X. So what is the intersection of this? Because I have to satisfy both conditions. X has to be bigger than 0, as x has to be bigger than 1. Then the intersection, as we draw here, that's x greater than 1. So this is one solution. Then another one is saying both be negative. That means x less than 0, x minus 1 less than 0. So this I have to put an end. We have to satisfy both conditions. So x minus 1 less than 0 is x less than 1. And a number less than 0 and less than 1 has to be less than 0, right? So because it has to satisfy both conditions, again, we can draw a graph like this, right? With less than 0, it must less than 1. So I have two solutions. I have solutions is x either greater than 1 or x less than 0. So that is the domain. The domain is saying x value either bigger than 1 or less than 0. The function does not work for the values in between of those. All right. Any questions? Okay, so I'm going to assign you homework for. Well, let's try. Actually, let's try. Let me see. Let's try. Let's try now. Let's try a couple of this now. Try 63. Okay, try 63, 64, 65, and 66. Okay, let's try. I'm gonna give you maybe like 7 minutes to try those 4 questions. If you want to show your work, if you want to take this time as a presentation, write the number on the chat. Okay, Rina wants to do 64. Anybody want to try 63, 65, 66? 65, 66, both are similar to 70. Okay, you have to go through the process solving inequalities. Okay, Rina, if you're ready, go ahead. Okay, Natalie, 63. Okay, get yourself ready. Or you can use the whiteboard to explain, all right, because 63, 64.
Okay, should I go now?
Yeah, go ahead.
I didn't take the picture yet, so
It's okay.
send a textbook so that you can.
You can just explain to us what you did.
Okay, so for 63, can you pull up the textbook?
Oh, okay. You see, I can read for you.
Yeah, okay, thank you. So for 63, x plus 3 greater than 0, and then minus 3 on both sides. You're just gonna have x greater than negative 3.
That's it, right? That's the domain of this function. This function is log base 10 x plus 3. So how do we find the domain? We take the expression inside the log x plus 3. We set to greater than 0. We minus 3 on both sides. The domain is x greater than negative 3. That's it. If you want to be precise, put a wiggly parenthesis around it to indicate this is a set, or we can write as negative 3 up to positive infinity. Right? We can write it in interval notation or in this set notation. Okay, good job. Right. So, Rina, are you ready? You can just do the same. I'll write for you. You can just explain it.
So for 64, I have to set the inside the 8 minus 2x to greater than 0. And then I solved for x, so you do minus 8.
Minus a on both sides.
Yeah. And then you divide by negative 2. So since you're dividing by a negative number, you have to change the sign to the other side. And then you get a 4. So since x is less than 4, the domain is from negative infinity to 4.
Good job. Okay, so we can write in an interval notation. We write as negative, infinity, up to 4. All right. Thank you. Thank you, Rena. Anybody else want to try 65 and 66? 65, 66, very similar to 70. All right, 70 I wrote up here. So, you know, maybe try when you have time. Now, let me talk about, because I assign you homework. 53 up to 58. Let's check. So 53, 54, 55, 56, 57, up to 58 to practice to find the domain of these functions. Right, you may do by plotting some points or by using the reference graph to graph it, all right? So then 68. 68 is this one. It's a little bit complicated because we have to consider the domain of this part, square root and the square root sign. Remember, under square root sign, the expression cannot be negative. Cannot be negative. We write it can be 0, right? So we write this x minus 2 less than or greater than or equal to 0. Then we have to consider inside the log. Inside the log has to be greater than 0. Then we take the intersections because x has to satisfy condition for this and condition for this. So then you take the intersections. If it's difficult, you draw the real number graph. You draw a real number line to try to figure out. All right. So 68 is a little bit challenging. Let's see, 75 to 78. So 75 to 78, what do we have to do? We have to find a composition of functions. If you remember, we talked about this, right? This means f composed with g. So let me just remind you one of this. So let me try 76, f composed with g. Remember the circle in between just means this. F composed with g just means f take g as the input. Right? What's g? In this case, that's x squared plus 1. Then we have to follow the function for f. How is function f defined? Function f defined as 3 raised by x. 3 raised by the input, right? So 3 raised by the input. What's the input? The input is x squared plus 1. So my f composed with g is just 3 raised by x squared plus 1. Right? The exponent of 3 is a complicated expression. If I do g of f, right, g composed with f for the second part, that means g takes f function as the input. Right? G takes f function as input. I just follow the same procedure. I write g of 3 raised by x. Then how is g defined? G is saying square the input, then add 1 to it. So I'm going to square the input, add 1 to it. Okay, I'm not going to do it. So you try, you practice. All right. So this practice is to remind us about the composition of two functions. All right, any questions? All right, try this homework and try this two unfinished X65 and 66. All right, so we'll talk about next time. All right, anybody has any question? If not, have a great weekend, all right? If not, have a good weekend. And if you have any questions, I'm still here. Thank you. Have a good day. Have a good weekend.